Here I'm going to find the modulus. I'm going to factor it out and get -4/5 and -3/5. Two ratios I don't tend to get with any special angles that I would have. So here I have to do some evaluation and say, okay, well, one of the reasons why I start dealing with the reference angle, if you notice, I do know that if I'm looking at my complex number plane, I know that -4 minus 3i is going to put me down in this quadrant here somewhere. Okay. The thing is, you know, when I start going back to trig functions and things like that, because I'm trying to find a value of theta that's going to give me these two values at the same time for the cosine of theta and the sine of theta, if it's at all possible. So at some point, as you notice there, I'm going to have to take an arc cosine. Now, arc cosine would only give me angles in one of these two quadrants. So that would give me that would be a problem, because I'm in the third quadrant, whereas arc cosine would only give me answers in the first and second quadrant. So here I'm going to need a reference angle. So I just take the arc cosine of 4/5 and get about 0.6435 radians. But I realize that's alpha. So, and that means in this figure down here, this is alpha. And I also know that this is pi. So according to the figure, for me to find the value of theta, which is this whole thing here, I'm going to have to take pi plus the value of alpha, which would be, in this case, the arc cosine of 4/5. So when I do that, I get about 3.7851 radians. Which means that if I'm writing this in a more polar form, I'm going to have 5 times the cosine, 3.7851, plus I times the sine of 3.7851.